Welcome to our 7-1 notes, and thank you for joining me. So this notes is all about zero and negative exponents. So the first thing I would like you to do is please write down our objective in your notes, okay? We're always going to start with the objective because this is what we want you to get out of the notes today. So today all we're doing is learning to apply zero and negative exponents. Now, first of all, we're going to review what some of these exponents do, okay? So for example, 8 squared. So I'm hoping you guys know 8 squared just means 8 times 8, which is going to give us 64, okay? Pretty basic question. Now, let's look at this x squared, okay? We're going to look at it two different ways. So first, when x is negative 3, okay? So we're going to take negative 3 and square it. So literally we're saying negative 3 times negative 3. Well, negative 3 times negative 3 is going to give us a positive 9. That square makes it positive. Well, what about this negative x to the 4? Let's take a look at that. So we have the negative up front, and then negative 2 to the 4th power. Okay, now notice what I'm doing. When I'm substituting a number in, notice I'm putting parentheses around that number. That's going to be pretty important all through this course and a good habit to get into. Whenever you're substituting a number in for a variable, put parentheses around it. Okay, so negative 2 to the 4th power. Okay, maybe you don't know that one off the top of your head. So negative 2 to the 4th power, just in case you don't know off the top of your head, that's going to give you 16. All right? But not only is that a 16, but notice we still have that negative out front from before. Okay? So negative 2 squared gives us 16, but there was the negative out front. Learning those little nuances like that are going to be extremely important when dealing with powers. Okay? So we're going to start with a little discovery. Okay? So in this discovery, we're going to talk about zero and negative exponents to see what happens. Okay, so 2 to the 4th power. Well, we just kind of talked about that one, right? 2 to the 4th power is 16. 2 to the 3rd power, I'm hoping you know this one. 2 times 2 times 2 gives me 8. 2 squared, I think all of you know, is 4. 2 to the 1st power, well, anything to the 1st power is just itself. Now, what about 0 power? Maybe we forgot. So again, so you don't just have to take my word for it, so you can actually see it. 2 to the 0 gives us 1. All right, so I'm going to put a 1 in there. Now for the rest of these, this is kind of the point of our exploration, our discovery here, is figuring out what's going on. So 2 to the negative 1, again, just so you don't have to take my word for it, I'm going to show you. 2 to the negative 1 gives me 0.5, okay? Now, I think a more useful form is we know 0.5 as 1/2, okay? 2 to the negative 2. Well, again, let's not take my word for it. Let's actually do it. 2 to the negative 2 is 0.25. And again, I think you guys will probably recognize that as 1/4. 2 to the negative 3 is 0.125. Now, maybe you don't know this one off the top of your head. So if you need, you can convert that to a fraction. That's going to be 1/8. 2 to the negative 4 is going to give you that. And again, you probably don't know that off the top of your head. So you can math frac that and get 1/16. All right, now I'm going to pause this video for a second because I want you to do that same thing for the tens, okay? So again, I'm going to pause the video. You with your calculator right now, do this next table, okay? Do the one for the tens, then unpause the video, and then I'll discuss what's next. All right, so now that you have that done, let's talk about what we're observing, okay? So first, I want to point out the relationship between 2 to the 4 and 2 to the negative 4. So notice 2 to the 4 is 16, 2 to the negative 4 is 1 over 16. 2 to the third is 8. 2 to the negative third is 1/8. 2 squared is 4. 2 to the negative 2 is 1/4. So I'm hoping you're seeing a pattern here, okay? So the pattern is every time I have 2 to the negative n, that's the same as taking 1 over whatever 2 to the n would have been, okay? Same thing happened with the tens. Notice that relationship. 10 to the 4 was 10,000. 10 to the negative 4 was 1 over 10,000. 10 to the third gives us 1,000. 10 to the negative 3 gives us 1 over 1,000. That same pattern happened. That negative exponent, all it did was shifted it down to be whatever 10 to the n would have been, but it's in the denominator now, okay? So that's going to be a very, very important rule throughout the rest of this lesson, okay? So I'm going to focus on this negative exponent piece on the right-hand side, okay? So we're going to write a general rule for negative exponents is going to be 1 over it with a positive exponent, okay? One way to think of that is, let's say you have a negative attitude. Well, people probably don't want to be around you. So what would your parents do if you're being negative? Well, if you're downstairs with them, they're going to send you upstairs. If you're already upstairs, they may send you to the basement to chill for a little bit. So that's what a negative exponent does. Think of it like a negative attitude. You need to move to get away from where you're at, okay? Now, what about a zero exponent, okay? This side right here. Well, zero exponent, let's go back up and see what happened there. 2 to the 0 was 1, and 10 to the 0 power was also 1. So this is actually a very interesting rule, that quite literally anything to the 0 power is simply going to equal the number 1, okay? Really easy rule. It's just one you have to keep straight is make sure you know that that is the number 1, okay? So now that we've done some discovering of these properties, let's go and practice them, okay? So we're going to determine what is the simplified form of each of these expressions, all right? So 4 to the negative 3, again, negative exponent, okay? Negative attitude can't stay where it is. It needs to move, okay? So I'm going to send that to the bottom. So that becomes 1 over 4 to the third power. Well, now 4 to the third power, if you type that in the calculator, 4 to the third power is 64. So I'm going to actually simplify that all the way to be 1 over 64, okay? Don't leave a number to a power, okay? Actually calculate that for me. Well, what about this one? I see a 0 exponent right here. Right away, when I see 0 exponent, I know that that is going to be the number 1. 3 to the negative 2, again, negative attitude. We need to move it. So I'm going to do 1 over 3 squared. Then again, you guys hopefully know 3 squared. 3 times 3 is 9. So I'm actually going to call that 1 over 9. In D, once again, I see a negative exponent, so it needs to move, clear out its negative attitude. Well, 6 to the first is just 6. So I would actually write this a little bit cleaner and just call it 1/6. Letter E, again, first thing I notice, negative exponent, so I need to move this down. Okay, so that's the first thing I clean up. And now negative 4 squared, Well, negative 4 times negative 4 is going to be a positive 16. So I'm going to get 1 over 16 for that. Next set. Once again, I see a negative exponent, so I'm going to move that down so it can get a positive exponent. So variables work the same way as numbers do in all of these rules, okay? B is a little bit different than what you've seen before. I see a negative exponent, but it's already in the bottom of the fraction, okay? But remember, negative attitudes work the same way. You just need to move from wherever you are to get a positive attitude. So instead of being on the bottom, I'm going to move the n to the 3 upstairs, okay? Which leaves nothing in the denominator. So that's really just going to be n cubed. All right, here, once again, I'm zeroing in on that negative exponent, that negative attitude that needs to move. Okay, so the 4 is fine. The B is fine. It's only the C that has that negative exponent, that negative attitude, so it needs to move. In D, again, negative exponent, so that A needs to move up to get a positive 1. And again, now there's nothing left in the denominator, so I don't even have to show it. Then E, well, the M is already fine, but the N has that negative exponent to it, so that needs to move downstairs, needs to get a better attitude. Nothing left on top, so I'm just going to toss a 1 up there if I had to move the only thing that was there. Okay, so not too difficult. You just have to remember those two properties. Anything to the 0 is 1. Anything with a negative exponent, think of it like a negative attitude. It just needs to move away from where it is. All right, now another skill to work on is evaluating exponential expressions. Okay, so now again, the big thing here is put parentheses whenever you're substituting a number in. Okay, so for number 1, I have a negative, then R is negative 2 squared times S, which is 3. Okay, so make sure you're putting parentheses around those numbers that you're evaluating or that you're substituting in. Negative 2 squared, well, negative 2 times negative 2 is a positive 9. Now, 9 times 3 is 27, and we still have that negative out front. So we end up with a negative 27. All right, now for number 2. Number 2, I noticed something. So I notice all of this is already being taken to a 0 power. The 0 power is affecting everything within that parenthesis. So because of that, remember what happens. Anything in that parenthesis is going to become 1. So I have that negative out front, but now that entire parenthesis just becomes 1. That one's kind of a shortcut. I don't have to actually substitute it in because I know that no matter what is in there is going to become 1 anyway. All right, number 3. So let's substitute R in. Let's substitute S in. So I'm going to deal with that negative exponent first, okay? Remember in PEMDAS, exponents come first. So I'm going to take that negative 2 and I'm going to move it to the denominator where it can become a positive exponent, okay? It needs to get a positive attitude. Now, the key thing here is, remember, being a negative number is different than having a negative exponent. This negative 3 right here, that negative 3 does not have a negative exponent. Being negative is different than that negative exponent, so it actually gets to stay on top, along with this 3 here. That also does not have a negative exponent. So be very careful. You're only moving things that are directly connected to that negative exponent, okay? So now let's evaluate this. On top, -3 times 3 will give us a -9. On the bottom, -2 times -2 will give us a +4. And there is our answer. All right, last page for our notes. So population growth. A population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1,000 times 2 to the h, where h is the number of hours after a scientist measures the population size. Evaluate the expression for h equals 0 and h equals 3. What does each value of the expression represent in the situation? All right, so I'm going to start with h of 0. So I'm going to plug that in. 1,000 times 2 to the 0. Well, being the clever math students that we are, we know 2 to the 0 is the same thing as 1. So this is literally just 1,000 bacteria. Okay? What about when I plug in -3? Okay, so 2 to the -3. Well, negative exponent, remember, it needs to get a better attitude. So that needs to move down to get a better attitude, okay? So 1,000, 2 to the third is 8. So 1,000 divided by 8 is going to leave us with 125 bacteria. All right, and they want to know, what does each expression represent in the expression? So 0 hours. 0 hours is going to be amount of bacteria when the experiment began. Okay, now -3. So if they started timing at 0, -3 would be amount of bacteria 3 hours before they began measuring. All right, so 0 is when they started measuring, -3, 3 hours before they started measuring. All right, and that is going to be all for the notes today. Now, I do want you to look at the bottom of your sheet, okay? Or I guess for you, it's the next page of your sheet. So this is going to be a summary. So what I want you to do is I want you to think about our objective, to use and apply 0 and negative exponents. And I want you to write a couple sentences about something you learned today about this learning objective, okay? Either a trick you picked up on or just anything that you learned today that will help you as we move forward throughout the chapter, okay? A good reflection practice on what you just learned. And then I want you to think, where would you be on a 0 to 4 scale, okay? Now 0 is, I still feel like I have no grasp of this. 1 or 2 is, I think I'm along the way. 3 is going to mean, hey, I think I'm where I need to be. 4 means you think you could do even more. If you could go above and beyond my expectation, that would be a 4, okay? So take a moment, write your summary, reflect on where you are on that learning progression, that learning scale, all right? And then you are done with your notes, and thank you for joining.